So before we jump into that, I got just two other cheesy little examples that I'll at least just kind of showcase so that when I look at the heat maps, they're kind of fun. So the first one is going to be what's referred to as a rat's maze. So what ends up happening here is that I'm going to put a little rat in. So here's my best drawing of a rat. No, that's awful, but no. So what's going to happen is this little rat's going to be plopped into, let's say, location 1. Technically, you could put it wherever. And that little rat's going to cruise around. So it's going to do some random little rat things. And then once it finds the cheese, it's going to stay put. So again, it becomes one of these nice little absorption chains, is that they're going to move around, kind of doing whatever it wants to, hopping around, doing all cool little rat things. And then the moment it finds spot 9, it's going to stay put. So you're going to see some big 9x9 array is going to be formed here. And the probabilities that are going to come into play are connected to how many places the rat can go. If there's 2 doors, then there's going to be even money that rat's going to go between those. If there's only 1 door, then it's going to be 100% chance that you have to go through it. And if there are 3 doors, then it's going to be, the 33% chance that we go through one of those as well. So if you look at this, you can see there's a whole bunch of ways I can get into that location 9. The shortest of which is what? If I go 1 to 2, so you can see that I can do that in 1, 2, 3, 4 moves total. But you can also see that there are ways that the rat would just sit and spin here forever and then eventually spring free. So it might be that it takes a really long time, or it might be that it happens really quickly. So what ends up happening is you can build, again, this giant little matrix and then blast through various powers and see the kind of evolution of the rat finally eventually kind of getting to that cheese. So that's one kind of cheesy little example. The other one, which actually came up in a discussion that Andrew Kramer and I were having a couple nights ago on Discord, is that he was playing the game of life, and he was chatting about various stock prices in the game of life, which if you remember to your childhood, the game of life has this little spinner, and you move around. So the spinner has between 1 and 10 as the outcomes. And if you buy a stock in that game, you get money anytime somebody, spins a specific number. So then it became this question of like, okay, how long does a game of life actually take? So there's like 120 some odd cells there. There's a couple little stopping places that emerge, and that you have to get a job, you have to get married, some other random stopping points along the game of life. So at some point in time, you have this notion of, okay, how many moves are there going to be and how many moves should there be on average? And can you weigh that with, whether or not buying a stock is good? So a simpler version of that game is the childhood game of Chutes and Ladders, which if you've not played recently is just this terrible childhood game of spinning a number, rolling a die or spinning a spinner. I don't even remember what the official thing is. And you cruise around a little board, going up ladders if you end up at the base of a ladder, or going down a slide if you end up at the top of a slide. So naturally, there's this question of like, okay, if I sit and play this game long enough, am I going to, win, or is my, niece or nephew just going to get mad and walk away? Like, how long do I have their attention for? And if you look at it, it's perfectly set up for one of these nice little absorbing chains. If I look at this little grid, I'm going to say that I start here at the location 1, and I'm going to roll a 1, 2, 3, or 4. So if you roll a 1, you actually go up to state 7. So if you think about having this as state 1, so you're going to have some probabilities. So here you can see there's a 25% chance that I end up at state 7. Likewise, I could go and I could roll a 2, which ends up at a 3. I could also do a 1, 2, 3, which actually moves me up to a 12. So I have a 25% chance of going up to 12. And if I rolled a 1, 2, 3, 4, I end up at 5, which slides me back down to 3. So there's actually 2 ways I can get to the 3. So there's a 50% chance after the first move, I'm actually going to end up at the 3. And you keep that little process going. So you have all of these little cells, and you make these cute little connections that are going to be formed between them, making this massive little network, and then again, letting this system evolve to see what happens. If you look at this one, you can hopefully see that some of these states are kind of dead states that you're not actually going to get to. There's no way you can actually be at state 2, because the moment you go into the 2 spot, you actually take the ladder up to 7. Likewise, there's no way you can actually be at 5, because if you land at 5, you have to take the chute on down. Same thing with the 4. So while it looks like this board initially has 16 cells on it, at the end of the day, you're only going to have like 8 or 9 states, because a bunch of these things can't ever be reached. This particular board is actually kind of evil, because if you look at, getting to the 12, you have to roll a 2. Otherwise, you're going to see some slides occur, or you could roll a 4. So you can have some really nasty boards that you could construct that, maybe forces the player to roll 3 straight 3s to get to the final end portion. So then the number of turns is going to be massive, because you're constantly stuck in these little loops. Here we got a couple little loops in that you could see the 3. If you roll the 2, you're back down a slide. 2, you're back down a slide, over and over and over again. But they kind of all come into play, and they're all kind of cute and fun. So you can, again, build this massive little kind of array to see all of that stuff unfold, and then we'll let that process just slowly evolve. So enough with the setup. Let's jump into some of the code, because it's fun to see those things actually evolve. So let me change my screen to